Hello? Yeah, fine. So now in the earlier class, we have seen about the fork system call, right? Now, in the fork system call, what we have seen that when the child process is created, one second, when the child process is created, everyone can, of you can hear me? Hello?
Yes, sir. Yes.
Yeah. Now, when the child process is created, it has the exact same code and data of its parent process. Now, in this case, what happens? Now we want a decision that let the child process have an independent code that sorry has a code that is independent from the parent process. Then what should be the process? Then the child to have an independent code uh, that is different from the parent, it should run the executive system call. The executive system call we have seen in this slide, that is slide number 4. Now the child to have independent code, it will run the executive command, right? Now what does the executive command call? Now the executive command is a family of functions which will terminate the currently running program and starts executing a new one, which is specified in the parameters of the executive in the context of the existing process. Now, let us say that you want to run a different program. Say, supposedly, you have run a C program and you have compiled it, and its objective, that is exe file, is stored in some of the file location. Now, you want your child process to run that code. So, in that case, what you should do, you should run this executive function to call that objective file to run for you on your behalf. But in this case, the process ID is not changed, and if the executive command failed, it returns 1. So using executive and executable binary files, suppose a.out can be converted into a process. So basically, we are replacing the child's code with basically with this one, that is a.out file. An example of using executive is implementing a shell program or a command interpreter. A shell program takes user commands and executes them. So how many parts are there? The executive family functions are basically 5 functions. Int execl, int execlp, int execle. So basically different paths and arguments are there. They all do the same thing. Excv. So basically it takes a constant argument also. Excvp. So these are all different files or functions which take input from the user or basically from the program function to execute a different binary file that is different from the code of the parent. So the first difference in this function is that there are 4 to take path name argument, and while the last to take a file name argument. So in this case, they take path. Now what is a path? Path is the basically the symbolic link to the executable file that you want to run. And what is the difference? Another file, and the file name arguments text is specified. If the file name contains a select, it is taken as a path name. Otherwise, it is an executable file searched for a directory specified by the path environment variable. So the executable file, if the path file is not mentioned, so in the path environment variable, that executable file is found out and run. You have understood this thing, what I have told you?
Except the
Hello?
last point.
Supposedly, if the file contains a slat, it is taken as a path name, right? To search the, basically, to search the file. But if the basically there is a path environment variable that we define in Unix. So the path environment variable is basically the bin file, right, where all the executable files are stored. Or you can define a different file, or you can define a different path environment variable to include your own desktop folder to and store all the commands or executable files in it. In that case, the executable file is searched for the directories in the specified in the path environment, similar that is stored in the Windows. Windows এ যেমন environment variable কে সবকটা path গুলো দেওয়া আছে, Unix এ এরকম করে path environment গুলো দেওয়া থাকে. In that case, the executable file is searched in those path environment, and the file is found out and it is executed. Okay, now understood, Pratik?
Yes, sir.
Okay, fine. So now executor CL. So takes the path name of a binary executable as its first argument. The rest of the arguments are command line arguments ending with a null. ঠিক আছে? So first it takes the path name of the binary executable wherever it is, and the rest of the arguments are the command line arguments ending with a, and whatever the command line arguments are, it should end with a null. execvs takes the path name of the binary executable as its first argument, that is this one, and an array of arguments as its second argument. So whatever the input data you want, that you can put as the arguments of the second command. So this one test dot say, let us say this is the file, and cat1.txt text.txt are the input. So this is an example. Bincp is the path name, and this is all the arguments. Empty string can be replaced by the command line itself, or leave it as it is. Another one is execlp. Execlp is same as the execl concept, that we do not have the give the full path name of the command. So we do not give the full path name of the command. It is just searched in the what is as the home directory or the bin directory. Fork and executive. When a program wants to have another program running in parallel, it will typically first use fork. Then the child process will use executive to actually run the desired program. So in this case, what happens? So when a program wants to have another program running in parallel, two programs it wants to run, it will use the fork command, and the child process will use the executive too. So basically what happens, the parent process will execute the fork command first to create the child process, and within the child process, the executive file will be executed to run the desired program. So wait PID, wait for the child process to stop or terminate. So basically, so okay, fine. Now this we have learned, executive file. Now another thing. So in this context, you have understood this one. Fork will create an executive file, child executive file. It will complete, it will run an exit command, and then it will return to the parent process that it has stopped. In this case, what happens? Wait. Whenever a parent executes a wait command, what it happens basically? It waits for a child, any of its child, to complete its execution. Then only it resumes the operation. So the wait blocks the parent from execution until one of its child executes. You have understood this one? This concept you understood?
Yes, sir.
Okay, fine. So what are the processes of the PID? What in star status, whatever the status of the child process is, PID with PID is basically PIDT, that is the child with status of the process ID of the child. What is the status? What are these options? So what happens? What is the wait command does do? It pauses or suspends the parent process until one of the child process is exited, or until a signal is delivered whose action is to terminate the parent or child process, or to call a signal handling function. So what is the use of this wait command? So it suspends the parent process, means it has to wait for any of its child to complete its execution, or any of the signal handling function is handled, till that a child waits, or sorry, the parent waits. After only a child terminates, if it gets a PID of the child that is returned, then only it will the parent will start its execution. Okay. So wait stops the process or the parent process to stop executing until one of the one of its child terminates. अच्छा ठीक है ये सोनी एक ये म्यूट कर दो बाबा. So to prevent the child becoming zombie, okay, zombie means the child has stopped executing, but basically what it happens, it still maintains the structure of it. Means although it has stopped executing, everything is finished, but still in the memory its structure remains. Okay, wait. So structure remains means it has all the memory structure is there. Means but it has stopped executing. That is what we mean by a zombie. To prevent the child becoming a zombie, the parent should call a wait on its children either periodically or upon receiving a signal child. That is what is the child signal sending, which indicates a child process has terminated. Only the parent process can kill or remove the child process. Okay, that is the job of the parent process. So if a child has already exited by the time of the call, the function returns immediately and the system resources used by the child are freed. So if the child is completed, if it is returned, if the PID of the child is returned, then the operating system takes all the processes or all the resources held by the child. It can be memory time, it can be system calls, anything. The call returns the PID of the child process on success. Right. The call returns the PID of the child process. So means the PID after the completion, the PID, the process ID of the child is returned. The status information allows the parent process to determine the exit status of the child process. The value is returned from main or passed by exit. So whatever the child process is, means whether it is running or whether it is whatever it is exit status or not, it is determined by the status information. So the parent process can determine what is the status of its child process from the this one, from the status information. If the status is not a null pointer, the status information will be written to the location to which it points. So basically, if the child is not stop executing, it will point to where the child is currently executing. So if wait PID, now let us say we are wait PID is the value of the PID. Let us say, okay. Now in wait PID, value of the PID can be whatever what is the value of the PID can be. So if it is -1, means the wait for any child or process whose process group ID is equal to the absolute value of the PID. It is basically to wait. So the parent waits for any process whose process group ID is equal to the absolute value of the PID. So if there is a process group ID of the parent is there, and if it is equal to the absolute value of the PID, then the parent has to wait for that child. Is equal to -1 means it means to wait for any child process. This is the same behavior which wait exhibits. -1 means any of the child should exit, then only the parent can, after it has received -1, then only it can, what it can do, it can further process or further run. If it is 0, it means the wait for any child process whose process group ID is equal to that of the calling process. So if a process group ID means basically, if you are creating a child process, it means the group ID belongs to that particular process. So the wait, we are waiting for a child process whose calling process is ID is equal to the process group ID. Greater than 0 means it has to wait for the child whose process ID is equal to the value of the PID. Okay. So this is the simple running of the code. So so basically what it does is actually PID wait is equal to wait and child status. So the fork command is running, right? And if the fork command is not equal to 0, the parent executes the wait system call. And what does the wait system call means? Wait system call means the parent has to wait for the system, for the child which was started by this fork system call. It has to terminate. Only after it terminates, then only it can write the child, the parent can write the parent that the child has terminated. So this is another system call that is another program to show about the this what you can say wait system call. So this is parent status. What is the fork system? So this in here we have started the fork system call. If the PID is less than 0, so there is an error. If PID is equal to 0, so this is the child. So basically the child is executing if PID is equal to 0. Else this is from the parent process. So if the PID is greater than 0, this is from the parent process. That means the parent process code is running. And in here it runs what is that wait and status. So there is only one fork system call, and when it executes the wait status, that means it is waiting for this child to terminate, and only after it terminates it can execute this command, that is printf child exited already now with exit status /n. Now you understood? If the parent executes this command, that is wait and status, that means only after the child has completed this command, right? Only after the child has executed this command, then only this code will run. That is printf child exited already now with exit status %d in status. Okay.
স্যার আরেকবার বলুন।
এখানে একটা চাইল্ড ক্রিয়েট হলো এই পজিশনে।
আচ্ছা
ঠিক আছে, যদি 0 হয় তার মানে এইটা রান করছো। চাইল্ড প্রসেসটা রান করছে, যদি না হয় তার মানে পেরেন্ট প্রসেসটা রান করছে। পেরেন্ট প্রসেসটা যদি রান করে, ঠিক আছে, তার মানে ও একটা ওয়েট সিস্টেম কল লাগালো, মানে কিন্তু চাইল্ডটা অলরেডি রান করছে কিন্তু কনকারেন্টলি।
আচ্ছা,
এবার যেই চাইল্ডটা রান করছে তার মানে ওর কি হলো, এবার পেরেন্ট হ্যাজ টু ওয়েট ফর দ্য চাইল্ড টু কমপ্লিট। চাইল্ডটা কি রান করছে, এইটা যখন প্রিন্ট করে দেবে, তারপর যখন এক্সিট মারবে, তখন ও পেরেন্টটা এই স্ট্যাটাসটা পেয়ে যাবে, হ্যাঁ দ্য চাইল্ড হ্যাজ কমপ্লিটেড অর ইট হ্যাজ টার্মিনেটেড। দেন অনলি after the child has terminated and all resources are cleared by the system or by the operating system, then only the parent will write this code, that is child exited already with exit status percent, whatever the exit status is. বুঝতে পারলে?
আচ্ছা স্যার, মানে ওইটা ওয়েট এন্ড স্ট্যাটাসটা ওই স্ট্যাটাসটা চেক করে এগোচ্ছে, তাই তো?
হ্যাঁ, একটাই চাইল্ড হয়েছে, ক্রিয়েট হয়েছে, ঠিক আছে।
আচ্ছা আচ্ছা,
যদি অনেক কটা ওয়েট কমান্ড থাকতো তাহলে মানে অনেক কটা চাইল্ডের ওয়েট করতে হলো। এখানে একটা চাইল্ডই যেহেতু ক্রিয়েট হয়েছে, ওই একটাতেই ও বুঝে গেল যে ইয়েস মাই চাইল্ড হ্যাজ কমপ্লিটেড হিজ প্রসেস।
ওকে ওকে, ঠিক আছে স্যার, ওকে।
Okay. So now this is print. So this is again wait null and null. So there are two system calls. There are two child processes are created, right? First this one, or one child process is created, another child process that is created by this one, right? Fourth system call. So at least there are three processes that are created. ঠিক আছে, মানে একটা চাইল্ড, একটা প্যারেন্ট, তার দুটো চাইল্ড হবে, ঠিক আছে। নাও এখানে দুবার ওয়েট নাল করলো, তার মানে ইট ইজ ওয়েটিং at least one of the processes to be complete. Whenever it is waiting one of the child processes to be complete, then only it can stop executing. The parent process can stop executing. বুঝতে পারলে?
হ্যাঁ
হ্যাঁ স্যার।
এবার ঠিক আছে, এবার তোমরা একটা কাজ করো। আচ্ছা, এখানে আরো আছে। So basically now this is the main function. Now in here though there are two fork system calls are running, ঠিক আছে। What is the parent PID, মানে যদি parent মানে যদি what is the child PID এখানে লিখবে, my parent PID কি এখানে লিখবে, get PPID get PPID, ঠিক আছে। get PPID writes the parent ID of the PID of the parent child, এটা এখানে প্রিন্ট করবে। তারপরে while wait not equal to -1, যতক্ষণ না এটা -1 হবে, যতক্ষণ না সবকটা প্যারেন্ট, যতক্ষণ না সবকটা চিলড্রেন কমপ্লিট করবে নিজের কাজটা, ততক্ষণ পর্যন্ত এই প্রোগ্রামটা ব্লক থাকবে, প্যারেন্ট উইল রিমেইন ব্লক। When it becomes equal to -1, then only it returns 0. ঠিক আছে, বুঝতে পারলে? হ্যাঁ না
হুম।
কার অসুবিধা হয়েছে বল?
না স্যার, ঠিক আছে।
Okay, fine. Now, how a system executes, basically exiting a process. Now, if you want to exit a process, if I want a child process to exit the process, what it will exit? It will put the exit command in status. So basically, what is the exit purpose? So exit, if it is exit is successful, it will give 0 or it will give 1. ঠিক আছে, you use the exit command to exit the process currently running. এটা basically সবাই use হয়। So we learned all these commands: fork, executive, wait, exit, system calls, binary file কিভাবে রান করতে হয়, এগুলো সব আমরা শিখলাম। এবার বলো তোমাদের কি কি কোশ্চেন আছে এই চ্যাপ্টারে, এই মডিউলটাতে। Any question?
না স্যার, আমরা দেখে নিই পাওয়ার পয়েন্টটা, তারপর যদি কোনো কোশ্চেন অ্যারাইজ করে বলবো।
আচ্ছা, পাওয়ার পয়েন্টটা তাহলে পাঠিয়ে দিই।
হ্যাঁ হ্যাঁ, আপনি শেয়ার করুন, তাহলে দেখে আর কি করতে পারবো।
দাঁড়া, পাঠিয়ে দিই। এই তোদের রোল নাম্বার এগুলো দিয়ে দে, রোল নাম্বার গুলো দিয়ে দে।
ঠিক আছে, দিচ্ছি।
এই সৌরভ কেন আসছে না রে?
ঘুমাচ্ছে স্যার। ঘুমাচ্ছে, ঠিকই বলেছিস।
বার করতে হবে। আচ্ছা, এনি কোশ্চেনস ইউ হ্যাভ? আচ্ছা, আমরা এখানে একটা জিনিস দেখে নিই আমাদের কি কি বাকি আছে। আচ্ছা, পেরেন্ট চাইল্ড রিলেশনশিপ হয়ে গেছে। আচ্ছা, হোম ভ্যারিয়েবল তোরা জানিস কি? আইনোড নাম্বার জানিস মনে হয়, ডট স্ল্যাশ অপারেটর এগুলো বোধহয় জানিস। এগুলো আমরা ইয়েতে করে নেবো, এগুলো আমরা লাইব্রেরিতে করে নেবো, ঠিক আছে, সরি ল্যাবে করে নেবো।
হুম হুম
ঠিক আছে? ঠিক আছে, এগুলো কোনো ব্যাপার না। আমরা আমরা তাহলে সেল এন্ড প্রসেসে চলে যাবো নেক্সট ক্লাসে। ঠিক আছে, কালকে তোদের ইয়ে আছে
সেল
না,
এন্ড
প্র্যাকটিক্যাল
প্রসেসটা
আছে
একটু
না?
ইজি মনে হচ্ছে স্যার।
হ্যাঁ কাইন্ড অফ ইজি মনে হয়।
দাঁড়া,
সেল এন্ড
easy?
প্রসেসটা একটু
ঠিক আছে,
ইজি।
তোদের এটা ইজি তো? শিওর তো?
প্রথম দুটো পয়েন্ট থেকে বলেছি স্যার, বাকি
হ্যাঁ
আর
হ্যাঁ
দেখিনি।
হ্যাঁ, ঠিক আছে, তোদের ইজি মনে হচ্ছে তো? হ্যাঁ কি নাতে বল।
স্যার
মানে
আপনি তো
কিছু
কপি
কিছু
এর
কমান্ড
ফাইলস
জানা
ঠিক
আছে।
আছে, ঠিক আছে,
স্যার
আমি
এর
বুঝে
একটা
গেছি তোরা তো ঠিক আছে,
না
সেই হিসেবে
না
এবার
স্যার
আমি
সেটা
প্র্যাকটিক্যালটা
বলছি
সেই
না না
হিসেবেই
না
করবো।
আপনি সিরিয়াসলি নেবেন না স্যার আমাদের কথা।
স্যার
আমি
আপনি
না
যে
না
কপি এর ফাইল শুধু স্যার দেখিয়েছিলেন তো স্যার ওটা দেখে বলছে স্যার, এর আগে আপনি স্যার
হ্যাঁ,
দেখিয়েছিলেন সেই জন্য।
না না, এবার
স্যার
দাঁড়া,
হাউ টু কপি এ ফাইল স্যার দেখিয়েছিলেন।